Hello everyone. Let's continue our discussion about probability and distribution. So in the last video, I talked about the very basic probability and some rules, and those rules and those knowledges is quite useful when we are dealing with pretty simple probability questions. Things like drawing some balls from a bag, drawing cards from a deck of poker cards, and assign some students to groups. However, in real life, we usually we in real life questions is often much more complicated. The sample size we get in real life is much larger than those simple questions. So once we have a very large sample space, a lot of sample points, we can see that there is some kind of pattern embedded in this sample space, and based on those patterns we can we can classify different we can classify them we can classify different types of sample space into different kinds of distribution. So that's why we often put probability and distribution together. We use distribution, we use the pattern of distribution to get the probability that we want to know. So as you can see here, basically we have two types of distribution. The first one is discrete random variables, and the second one is continuous random variables. The differences is that the first one is countable. There is I can say finite number of sample space, and the sample space is discrete from each other. It's not continuous. And the second one, of course, is continuous. There could be infinite number of sample space, and the infinite number of sample points, and those sample points can be continuous. They don't have a very foreseeable distance between each other. So let's see first type of random variable, the discrete random variable. So there's two simple requirements for discrete random variable. That's pretty simple and easy to understand. What we need to pay attention is the measure of discrete random variable. This is how we calculate mean, and this is how we calculate standard deviation. So if you look at these two functions, we have learned binomial distribution, hypergeometric, and Poisson distribution, right? And no matter what kind of distribution we're dealing with, as long as it is discrete random variable, its mean and standard deviation and variance can be calculated based on these two formulas. So these two formulas is universal. It's applicable to any kind of discrete random variables. However, when we are dealing with a specific type of discrete random variables, it is more useful to memorize the formula that's specific to that type. Of course, you can use the general formula, but it's less efficient. So let's move on. The first type of discrete random variable is binomial distribution. Well, we did some exercise in the recitation, and I'm sure everyone have a general understanding of what is binomial distribution. For binomial distribution is that for the experiment you're doing, no matter what kind of experiment you're doing, for a single event, or I should say for a single sample point, you you only have two possibilities. It's either A or B, either yes or no, either success or fail. When you combine a lot of such kind of sample points, then you get binomial distribution. And how to calculate the binomial distribution is based on this formula. How to calculate its probability, how to calculate the probability of success of yes or of A's. It is pretty straightforward, right? So we can see that if the probability for A is P, and we did n times of experiments, the probability of x time the experiment turns out to be A is that first we need to have x times of A, right? So it's P. And the n minus x time, since it's not A, then it should be B, because we only have two possibilities, right? So it's 1 minus P. And we talked about combination here in the last video. Combination, basically this means that from this n experiment, we need to select x experiment and its result is A. So how many combination we can get of if we select in this way. So this is the way to calculate its combination. And remember that this combination is without order, which means that we don't care if it's no, I'm sorry, let me rephrase it. Without order, it means that if we have if we have three events, let's say, for example, three events, one possible outcome could be the first one is A, the second one is A, the third one is B, right? Another possible outcome could be the first one is B, second one is A, and third one is A, right? Let me write down here. This is the first possible outcome. This is the second possible outcome. And we use combination. We say combination has no order. So which means that we treat these two outcomes as the same outcome. Which means that we don't care about order. We just care about the number of A's in here. As long as the number of A's is the same, then it's the same outcome. So that's how we calculate the possibility. And this is how we calculate mean, and this is how we calculate mean and the standard deviation. Of course, you can deduce how to calculate from these two formulas, but it's easier to remember this, right? Because these two formulas is specifically designed for binomial distribution. Okay, so that's about binomial distribution. So from now on, every single kind of distribution we learn, we just need to focus on 3 points. The first one is, of course, what kind of distribution is that? The second one is how to calculate probability. And the third one is how to calculate mean and standard deviation. That's the only thing we want to know about a distribution. That's the only thing we care, right? Okay, let's move on to Poisson distribution. This Poisson distribution may seem a little hard to understand at first sight. You may think, well, the description of Poisson distribution seems familiar, but why the formula is not familiar? Why is calculated this way? To be honest with you, I don't know why Poisson distribution is calculated this way. Why I don't know why the formula is like this. But just remember, this type of distribution is called Poisson, and how to utilize it. That's enough. That's all we need to know. So let's take a look. What is Poisson distribution? There's not a very there's not a very specific definition, but you should know that a distribution is Poisson distribution. I'm getting very practical here. I'm just telling you how to do Poisson distribution for assignment and exams. But in real life, I really know little about this. So if you see in a question or in exam, it lets you calculate the probability of number of events that happens in an interval, a given length of time, a given length, a given area, or a given space. It gives you an interval and asks you the probability of specific number of events. Then it's Poisson distribution, right? I list some examples here. You maybe you can take a look. Then it's the Poisson distribution. And how to calculate that probability is listed here. X is the number of events in that interval, and X is the probability you want to know, you want to calculate. And this, how to say this? Epsilon. This epsilon here seems a little bit tricky. The tricky part of Poisson distribution is to know epsilon. You need to know how to find epsilon. Sometimes, no, very often in questions they won't give you directly the epsilon. You need to calculate epsilon for yourself. Right? For example, the let's take a look at this example I list here. So you want to calculate. Let's be more specific. I want to calculate the possibility of three people, three customers or no matter comes in 20 minutes. I want to calculate that possibility in 20 minutes. Right? And I tell you, let me think. I tell you that based on our observations, for the last couple of days or whatever, based on our last observations, normally there will be let me rephrase it. Based on our observation for the exam, for example, for the last 100 days, this is our observation for last 100 days. The average people comes in is 100 people per day, right? Per day. So I want to calculate this probability. Now you know X, right? You take a look at the formula here. You have X, and you know E. E is a natural number. It's a constant number. The only thing you don't know is epsilon. So what is epsilon? I have already tell you that this is our observation we have. So if you take a look at the definition of epsilon, it's the expected number of events in unit. We have an observation in the past 100 days. And now for the 101 day our expectation is that in 20 minutes, our expectation is that in 20 minutes, there'll be how many people coming? There'll be 100 divided by 24 and divided by 60 over 20. So this is our expected number of customers that will come in 20 minutes. So you see, the trick here is to find the epsilon, is to calculate the epsilon. Once you get epsilon, you can get the probability, the mean, and standard deviation. So this is about Poisson distribution. You need to identify it, that this kind of situation, we need to use Poisson distribution, and how to get the epsilon. The last type of discrete random variable is hypergeometric. This sort of looks like a binomial distribution, but it's not. It looks like it's pretty similar, but it's not binomial. It could be it have more than two possibilities. So the definition is that you have n total elements, and in this element you have r numbers of event A, or if I use another example, you have 100 numbers of balls, 100 number of balls, and you have 50 of red balls. Then you have n minus r, which means another 50 of black balls. Now you draw small n elements. For example, you draw 20 balls. The probability of x number of red ball, the probability of 10 numbers of red ball. So this is hypergeometric distribution. So if you just look at this, if you just look at the example I gave you, 100 balls, 50 red, 50 black, you draw 20 balls, what is the probability that you'll get 10 balls that are red? You know that you need to use combination, you know that you need to calculate, you need to use a formula like this. You just don't know this is hypergeometric distribution. But right now I just tell you this is hypergeometric distribution. So it doesn't matter, you just use this formula. The formula is easier to understand than the name, right? And this is the mean and standard deviation. It's a little bit complicated, but you don't need to know how do you calculate this, how to derive this formula. You just remember this is how you calculate it, and you need to identify R, capital N, small n. That's it, right? Now then, let's turn to continuous random variables. Continuous random variables. There's a probability density function. So for continuous random variables, because they're continuous, which means that we cannot really calculate the number of events. Right? If you see here the hypergeometric distribution, we have specific number, be capital N, R, N minus R, we have specific number. But if we turn to continuous random variables, we don't have such a specific number of events. There are infinite number of events. So how do we represent such a distribution? We use a probability density function. We use such a function. What is that function? it can be in various of shapes, but it's just a function like this. We draw a point. In the X-ray, it represents the value of your sample point, the value of sample point, each sample point. And the y y-axis, we have the probability of that value. And the probability density function comes in various shapes. If, for example, for normal distribution, we can have a shape like this. And maybe for other kind of problem, other kind of experiments, we might get a shape like this or like this, or even like this, whatever shape. You just need to remember the y-axis and the x-axis and what they represent. That's all. That's about this function. And the last distribution I'm going to cover in this video is normal distribution, which is a type of continuous random variables. So normal distribution, I just want to let you know that so far, this is what you need to know about normal distribution. And you also need to know normal distribution, I think, is the most important distribution that we're gonna have in this class. The second half of the semester is, if I remember correctly, is all about normal distribution. You can tell it from its name. It's normal distribution. It's so normal, right? Right? Everything in the world is follows a normal pattern, right? There's maybe some outliers, some some extraordinary people, right? But most of the people, they're normal, they're ordinary, right? And most things, they're normal and they're ordinary. So the pattern they have is normal distribution, which means that it's the most common distribution. Everything is normal. So that's why it's called normal distribution. It's so common and it's used so widely. So I just want to emphasize on this point. It is so important, and you really need to pay a lot of attention to this kind of distribution. However, unfortunately, I cannot prove it to you how we get this function. It's just so complicated, and to be honest with you, I don't know how they derive this function. How they derive such a complicated function from a very, very normal, ordinary distribution. I don't know. But I don't know, but you just need to remember it. A distribution with this kind of function is normal distribution. And you have seen this graph in class, right? That normal distribution we usually represented with n, and here is mu, and this is not c, sorry, should be sigma. Is that it's delta or sigma? Should be sigma. It's the standard deviation. This is how we represent normal distribution. And you can see the graph here, different function has different mu, have different mean and standard deviation. And we can also see in the function that it has mu and it has standard deviation. So this graph is just a representation of its function. So different mu and different sigma will have different shape of graph. And the mu, the mean is really just is really just decide the the symmetric axis of the graph, right? You see different mu has different symmetric axis. This is -4 here, and this is these two are 0, this one is 3. And the standard deviation, the sigma, is just decide how wide is this graph, right? If you take a look at this too, obviously the gray one has larger standard deviation than the well, what is this color again? Well, anyways, than this one. Purple one. The purple one. Sorry, I just forgot what is this color's code. Then the purple one, right? The gray one has greater standard deviation than the purple one, which makes it wider, and essentially lower, right? Shorter than the purple one, wider and shorter. Right. So this is about a graph. Let me erase this because I want to talk about something else. And you remember the 3 things that I just mentioned about every kind of distribution. We need to know 3 things. The first one is definition. The second one is how to calculate probability, and the third one is how to calculate mean and standard deviation. So for normal distribution, as you can see, its function, that the mean and standard deviation is already in this function. So we don't need to do too much calculation. But if you want to do calculation, you can refer to the equation here. So always remember these 2 equations, they are the most general equation. They're general. They are applicable to all kinds of distribution, right? If you want to calculate the mean and standard deviation, these 2 are the most general. They are always useful. Back to normal distribution. That's the mean and standard deviation and its definition we all got. Right now, the one last thing we need to know is how to calculate the probability. So this function, this is how you calculate its probability. You can, Greg, remember I mentioned remember here the probability density function, right? The x-axis is about value. The y-axis is about probability. And remember how we this 2 equation doesn't help too much if we want to calculate probability. So let me put it in this way. So if you want to calculate a probability for normal distribution, all you need, let me use this one as an example. If we want to calculate, what is this? This is, here is 3, right? If we want to calculate probability of a value of x lying between 3 and 4, so it's essentially this place here, right? Lying between 3 and 4. Yeah. Why is between 3 and 4? Why is just not px equal 3 or p3? Right? Because before we always do like px, right? Here px, but why here we don't use px? We use a range, px in a range. Remember, this is a continuous distribution, continuous variable distribution. It has infinite number of sample points. You can just imagine there are infinite number of sample points. And for each sample point, it's just for each sample point, it's just this very small slice here. So there's no meaning to calculate that. And that's why we use a range here. We need to know the range. These sample points are continuous. And the probability that lying on a very specific point is so small, it's so small, that there's no meaning to calculate that. We just need to know a range, right? You're continuous. Okay, I assign you a range. You can be continuous inside my range. And my range is meaningful to calculate. So you know calculus, you know integral, and you can see the probability between 3 and 4 is just the area of this shape, right? Including the line here. It's just the area of this space. Right, as I mentioned, if I want to calculate the probability of 3, it's just this small slice. What about probability of 4? This small slice. Probability of 3.9, this small slice. 3.8, this small slice. So if you add all these slices together, they become this shaded area. So that's, oh, sorry. So that's what this function means. You know your calculus, you should know this function. It's essentially the area between 3 and 4. So that's how you calculate probability. Okay, one last point about normal distribution. About normal distribution, you can already see in this graph, right? We have different mean, different standard deviation. We're gonna get different shapes of curves. It is very annoying. It is very annoying in real life that whenever you do a normal distribution, you have different mean and different standard deviation. And whenever you want to calculate the probability here, you have to do the complex calculus, this integral. Whenever you want to calculate, you have to do it again. And remember, you have to do integral on this equation, on this formula here. Can you imagine how difficult is that? To be honest, I don't know how to do integral with this equation, right? So for the sake of simplicity and for the sake of easy to calculate the probability, easy to use this normal distribution because it's so normal, we have to use it so many times, so we want to make it simple. Then we need to make a standard version of normal distribution. A standard version of normal distribution means that no matter what mean and standard deviation you got, you can transform your distribution into the standard version of distribution. And you can see here, that's how we standardize it. How? Remember the z-score we learned before, the z-score? We standardize it by using the z-score. So now we transform every normal distribution into a normal distribution with a mean of 0 and a standard deviation of 1. You can think like this. We just move the mean from 3 to here. Then its mean is at 0, right? Everyone's mean is at 0. We move this mean here to 0. Everyone's mean is at 0. And if your mean is at 0, that's not enough. because you could have different standard deviation here and here. But remember, the z-score is standardized. How do you calculate z-scores here? Sorry, the z-score is here. The z-score is standardized. Different kind of distribution, they have a standard z-score because you divide it by the standard deviation here, then everyone is the same. So we just transform every kind of normal distribution into the standard one, which has a standard deviation of 1 and a mean of 0. So then we have the table you see in class, which is which is the probability of the standardized normal distribution here. So basically, it shows that what is the area of what is the probability of these areas, right? If you want to know the size of this area, you can just look up in the table. That makes things much easier, right? Right now, you just need to look up in the table. You don't need to have to do the integral to calculate the area. So that's how we standardize things. And in the future, we'll always work with the standardized normal distribution. We'll never work with the really normal distribution. We'll work with the standardized one that makes things easier. And if you want to know probability, you can just look it up in the table. That's much more easy. Okay, so I will just stop here. Normal distribution. Really need to understand what I just talked about today. And it's gonna be very helpful for the chapters following, for the following chapters. So that's all I want to say about in the second video about the probability and distribution. And in the third video, we'll finish up with the distribution. Okay, so that's it. Bye bye now.